Hello! Welcome to Honest Physics Lesson 8.4 Torque, where if you can dodge a wrench, you can dodge a ball. Alright, so let's talk about torque. So previously we've already talked about force causing an acceleration, right? So that's in the second law, where force equals mass times acceleration. Torque, or net torque, this causes an angular acceleration. So this is our angular component for torque. So torque is a measure of how much force is going to cause an object to rotate. And the torque produced by a force is directly proportional to two things. So the force that's being applied and the distance that it's being applied from the point that it's rotating around. So this pivot point is the point where the object is actually rotating. Right? And the distance, how far you are from that pivot point, gives us something called the lever arm. And it gives us this formula here, where torque equals our force times our distance, which is also proportional to whatever angle that we apply to said torque. Alright, so let's practice some of this. So let's take this wrench, and it's got a bolt, and kind of keeping with our theme, if you can dodge a wrench, you can dodge a ball. We're trying to figure out the torque. Alright, so the wrench itself, about 10 centimeters long. So from here to here is 0.1 meters. Right, so if we're applying a force of 12 newtons at the end of the wrench, so over here somewhere, so 0.1 meters away, what we're going to end up with is 12 times 0.1 meters. And we should get 1.2. And it's plus or minus, because I can either rotate this way or this way. So we think about our right hand rule. Take your right hand, put your thumb on the bolt itself, and you can either rotate counterclockwise, which is going, you can either rotate clockwise, which is going inwards, right, righty-tighty. That would be down. That's our negative direction. Or you can go counterclockwise, which would be positive, right, making the bolt come out, which would be our lefty-loosey. Either way. And that's the only one that I'll show you as positive or negative. For the most part, I'm just looking for the amount of torque. You can just go either way. Okay. Moving on. Let's try some more. So let's say we apply that 12 newtons, but now, instead of at the end, I'm going to apply it at the start of the handle. Right? So the very start of the handle. Looks about 2 centimeters or 0.02 meters. Still applying it directly, so we're having 12 times 0.02. We should end up with 0.24 Newton meters. Alright, let's see what happens if we apply that force directly in the center, so right at the pivot point. What's going to happen then? Well, now our distance is 0, so our torque is 0, and it's not going to be able to rotate. What if we were able to extend this wrench? So now our wrench, instead of being the 10 centimeters long that it was, it's going to be quite a bit longer, let's say 16, so 1.16 meters long. And we're still doing it at the end of the pipe, so just completely direct, perpendicular to the wrench itself. So we'll have 12 times 0.16, and you should notice that the torque increases. Right? The torque should increase. Alright, but what if now, instead of going perpendicular, we go on an angle? So we apply a force that is at the end of the wrench, but now it's at 30 degrees. So now all of our force isn't going to move it this way or this way. It's going a little bit that way and a little bit this way, right? So that's going to take away from our force. So that's where that sign of our angle comes into play. So we're going to have 12, and it's still the same wrench, so it's still at 10 centimeters times the 0.1 times the sine of 30. And that should give us our net torque, which is much smaller, 0.6 Newton meters. Okay, real quick, easy, kind of direct to the point. I will see you next time. Goodbye. What? You're still here? Say goodbye. It's kind of the universal thing for saying bye, right? Huh? Go. Go do something. Huh? Okay. Goodbye. No, for real.